Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 24, Stoichiometry, Part 5. Here are our objectives for today's video. Pause here. We are going to be working with this equation for the entirety of today's video for every single example, so it would be useful to have it in its entirety. Right, so when we are relating chemical quantities, you're always going to need a balanced chemical equation because we can make unit factors for any two of the compounds or elements in this equation. So it doesn't matter if they're both on the left, both on the left and the right, both reactants, both products, does not matter. If I need to relate, say, oxygen and hydrogen, I take the coefficients from the balanced chemical equation and I can use it to create a unit factor, which is called the mole-to-mole ratio. So depending on what I'm trying to cancel out, I could have 15 moles O2 over 6 moles H2O, or the other way around. Again, just depending on what you need to cancel out. So approach these as dimensional analysis problems, and this is just one more form of a unit factor that you can use. Pause here. All right, so let's work through this. So I am starting with 5.00 moles of O2. And it's asking for how many moles of water. So I go to my balanced chemical equation. I see that there's a 6 in front of my H2O. So 6 moles of H2O for every 15 moles of O2. I had to put the 6 up top and the 15 on bottom because I needed mole O2 to cancel with mole O2. And then I just put this in my calculator and round to 3 sig figs, so 2.00 mole H2O. Now for the second one, it's asking for how many moles of C6H6 or benzene for every 3.22 moles of CO2. So I go to my balanced chemical equation. I see that there is a 2 in front of C6H6. And then I have a 12 in front of CO2. Make sure you put mole in the fraction. It will make your life easier down the road. And then I round it to 3 sig figs because 3.22 has 3 sig figs. So we are treating those coefficients as constants. Okay, now let's add on a step. Pause here. Okay, so this starts with grams of oxygen gas, which means that before I do my mole-to-mole ratio, I am going to need to convert that to moles using molar mass. But I wrote mole, I meant grams. Once I have it in moles, then I can use the mole-to-mole ratios in the problem. And then I need to round this to 4 sig figs. One thing that commonly confuses students is when a problem says produces or consumes, and there are experimental reasons why it says that, but it doesn't actually affect the way that you do the problem. Pause here. So not only am I starting with grams here, so I'm going to need to use the molar mass of CO2, but it's asking for grams, which just means that after I do my mole-to-mole ratio, I'm going to need to use molar mass again. And then because mole is up top in the fraction that comes before that, it has to be on the bottom in the second one. And then I round this whole thing to have 3 significant figures. You're never really going to see more than four fractions, or you're rarely going to see more than four fractions. And then we just have one more variety. Pause here. So I'm starting with moles, so that means I don't need the molar mass of C6H6. And then it's asking for molecules, which tells me I'm going to need to use Avogadro's number at the end. And then I just put this whole thing in my calculator. I round it to three significant figures. So I got 1.80 times 10 to the 25th molecules of O2. It got cut off, but it does say molecules of O2 at the end. All right, that is all for today's video. Thank you so much for watching and have a great night.